When tensions rise in the Middle East, the entire world pays attention. Oil prices jump, global markets react, and governments worry about energy supplies. And one region stretching across the Persian Gulf suddenly becomes the center of global headlines. The recent tensions involving Iran and Israel have once again highlighted how sensitive the global energy system is to events to this region. But the real story of Middle Eastern oil didn't begin with modern politics, countries, borders, or even human civilization. It began hundreds of millions of years ago when much of the Middle East was covered by a vast tropical ocean. Today, the Arabian Peninsula is known for its deserts, endless sand dunes, scorching temperatures, and dry landscape. But Earth's geography has changed dramatically over geological time. Between roughly 300 million and 50 million years ago, large parts of what is now Saudi Arabia, Iraq, Kuwait, and Persian Gulf were submerged beneath warm, shallow seas. These waters were rich with microscopic life. Tiny organisms such as plankton, algae, and marine bacteria thrived in these environments. Like all living things, they eventually died, and when they did, their remains slowly drifted down to the seafloor. Normally, dead organic material decomposes quickly and disappears, but in certain marine environments, particularly where oxygen levels are low, organic matter can accumulate faster than it decays. In these ancient seas, that's exactly what happened. Layer upon layer of microscopic life settled on the ocean floor, forming thick deposits of organic-rich sediment. Over millions of years, these layers were buried beneath sand, clay, and limestone. As the sediments piled up, the pressure increased. Temperatures deep underground slowly rose, and under these conditions, something remarkable began to happen. The organic material was gradually transformed into hydrocarbons, the chemical compounds that make up crude oil and natural gas. This transformation process is known as a thermal maturation, and it takes tens of millions of years. In essence, the oil that powers modern economies began as the remains of microscopic organisms that lived hundreds of millions of years ago. But generating oil is only the first step. For large oil fields to exist, several other geological conditions must also align. First, the organic-rich sediments must form what geologists call source rock, a rock capable of producing hydrocarbons. The Middle East contains some of the most productive source rocks on the planet. One famous example comes from Jurassic period, when marine environments beneath what is now the Persian Gulf produced enormous quantities of organic-rich sediments. These eventually generated vast volumes of petroleum. But oil doesn't usually stay in the rocks where it forms, because oil and gas are lighter than water. They tend to migrate upward through porous layers of rock. This migration leads to the next crucial component of an oil system: reservoir rocks. Reservoir rocks are porous formations that can store large amounts of hydrocarbons. Many of the Middle East oil fields are located in the carbonate rocks, particularly limestone and dolomite. These rocks formed in ancient marine environments built by coral reefs, shell-forming organisms, and other marine life. Over time, these carbonate platforms became enormous underground storage systems for oil. Their microscopic pores and natural fractures allow fluids like oil and gas to accumulate and flow. In some Middle Eastern reservoirs, the rock is so permeable that oil can move relatively easily compared with many other parts of the world. This is one reason why oil extraction in this region has historically been cheaper and more efficient than in places with more complex geology. But even if oil forms and migrates into a reservoir, it still needs one more thing to accumulate in large quantities. It needs a trap. Without traps, oil would eventually leak to the surface and disappear. In the Middle East, geological history created many of these traps. One important type involves evaporate rocks, such as salt and gypsum. These layers formed when ancient seas evaporated, leaving behind thick deposits of salt. Salt is extremely impermeable, meaning fluids cannot easily pass through it. When oil migrates upward and encounters a salt layer, it becomes trapped beneath it. Another type of trap forms through tectonic forces. Over millions of years, movements of Earth's crust folded rock layers into arches and domes. Oil migrating upward became trapped beneath these structures. These natural geological traps allowed enormous volumes of petroleum to accumulate over time. The result is something extremely rare in geology: giant oil fields. The Middle East hosts several of the largest oil fields ever discovered. Among them is the most famous Ghawar fields in Saudi Arabia, the largest conventional oil field on Earth. Stretching for roughly 280 kilometers, Gower has produced tens of billions of barrels of oil since its discovery in 1948. Other massive fields exist across Iraq, Kuwait, Iran, and United Arab Emirates. Together, the Middle East holds roughly half of the world's proven oil reserves. Few places on Earth possess such extraordinary geological abundance, but geology alone does not explain the region's strategic importance. Geography plays a major role as well. Much of the oil produced in the Persian Gulf must travel through narrow maritime routes before reaching global markets. The most important of these routes is the Strait of Hormuz. This narrow waterway connects Persian Gulf to the Arabian Sea and the wider Indian Ocean. Every day, massive oil tankers pass through this corridor carrying crude oil to Asia, Europe, and North America. Roughly one-fifth of the world's oil supply moves through the Strait of Hormuz. Because of this, it has become one of the most strategically sensitive shipping routes on the planet. Any disruption there, whether from conflict, political tension, or military escalation, can send shockwaves through global energy markets. This is why events in the Middle East often have global economic consequences. The modern era of Middle Eastern oil began in 1908 with a major oil discovery in Iran. Over the following decades, vast petroleum reserves were discovered across the Arabian Peninsula. These discoveries transformed the region. Desert economies rapidly developed into some of the wealthiest states in the world. Oil revenues funded modern cities, massive infrastructure projects, and some of the world's largest sovereign wealth funds. At the same time, oil also reshaped global politics. International alliances, economic strategies, and military interests increasingly revolved around access to energy resources. The Middle East gradually became the focal point of global energy security. Today, developments in the region still influence oil markets worldwide. When geopolitical tensions rise, such as the current standoff involving Iran and Israel, investors and governments immediately worry about the potential disruptions to oil supply. But behind all these modern events lies a much deeper story. The energy resources that shape global politics today were created long before human history. They were formed by ancient oceans filled with microscopic life. Sediments buried these organisms deep underground. Heat and pressure transformed them into petroleum, and geological forces trapped that oil beneath layers of rock for hundreds of millions of years. In a sense, the oil fields of Middle East are time capsules from Earth's deep past. Yet, the world is also beginning to look beyond oil. Renewable energy technologies, including solar power, wind energy, and green hydrogen, are expanding rapidly across the globe. Even many oil-producing countries in the Middle East are investing heavily in energy diversification. Despite this shift, petroleum will likely remain a critical part of the global energy system for decades to come. And as long as that remains true, the geological legacy of ancient oceans beneath the Middle East will continue to shape global economics and geopolitics. The tensions we see today may be driven by politics, security concerns, and regional rivalry. But beneath it all lies something much older, a resource formed hundreds of millions of years ago when the deserts of the Middle East were still ancient seas.